everyone, in this micro lecture we're going to talk about experimental research. Experimental research is wonderful. It helps us infer causality, and with great certainty we can say A causes B, right? It's looking at cause and effect, but it's doing so in a way that we can control everything else in the situation, or as much as possible. What do I mean by that? Well, let's say I wanted to conduct a study testing caffeine use and testing performance. I think that students who consume caffeine will score better on my final exam than students who do not. Okay? Do I just go to class, ask who has had any kind of caffeine today, and then see how they do on their test? No. Because there's so many differences, right? There's so many differences that could mess up my results. There's the types of students, how much they studied, how much caffeine they had, because some may have way more than others. What do you consider a good score? Did these students all take the test at the same time of the day? Even time of the day can affect that result. So we have to think about all these things that can muddy our results, because sometimes time of day could affect the test scores more than the caffeine use. And so what I want to do is try to isolate those two variables, the independent variable and the dependent variable, as much as I can, so I can say with a good amount of certainty, A causes B. Consuming higher levels of caffeine would lead to better testing scores. I want to say that, but I have to strip away those other variables as much as I can. And so that's what we're doing in an experiment. It's kind of the gold standard. It's trying to isolate an instance as much as possible. But what you have to do in experimental research in order to get to a point where you can say, yes, A causes B, you have to operationalize your concepts. So if I say higher caffeine use will yield better scores in students on the final exam, I have to define a few things. I have to define, what my sample is, what students I'm using, as well as caffeine use. I have to detail what I consider caffeine use. Is it 2 cups of coffee, 2 cups of espresso, sorry, please don't get mad at me, anyone who's like a big espresso person. Am I measuring it by milligrams? Anyone who's had more than 160 milligrams? How am I going to measure caffeine use? Okay? Then, I'm also going to have to define what good scores are, better scores are on an exam. What is the standard that I'm using to measure those scores? It has to be systematic, and I have to detail it, because I have to compare everyone to the same standard, right? And how am I even going to measure this in the first place? Maybe have one group drink coffee and the other not? There's an issue there. Because what if the group that's not knows they're not having coffee, so they think they're going to do a bad job? Maybe I need to put decaf coffee in front of them as a placebo. There's so many things to think about, right? But basically, I have to make it so I'm going to split these two groups. One group's going to receive caffeine and the other group is not. And then I'm going to measure their test scores. So with those two groups, though, if I take my classroom and I assign them in 2 groups, I am going to try to fake it so that both groups think they're getting the coffee. So then I know their expectations are not affecting their test performance. So that the group who has coffee doesn't think they're going to do better, so they do better, because the mind is a very powerful thing. But then I don't want the group that doesn't have any coffee to think they're going to do worse because they don't have coffee. So I'm going to give both groups coffee. Maybe I'll give one group caffeinated and the other one decaf. Okay, that's a good way to mitigate how our kind of self-fulfilling prophecies and our expectations can influence results. Okay, so the group that's receiving the treatment is called the experimental group. In this case, our caffeinated group is going to be the experimental group. They're the ones we're experimenting on. The control group is the group to which you would compare the results. They're the comparison group. So by not giving them caffeine, that second group is kind of the baseline we're going to compare the caffeinated scores to. Follow me? Okay? And in order for this to be a true experiment, we have to have random assignment. Now, what does that mean? It means that everyone has an equal chance of being in either group. I can't think, oh, okay, people who consume caffeinated coffee are going to do better in this group. Maybe let me put my good test takers all in the coffee group to make my results and my hypothesis look really good. No, everyone in the study has to have an equal chance of falling into either group. Okay? And what are your independent and dependent variables? These are the things that we are going to measure, right? So our independent variable is going to be whatever is manipulated within the study. In this case, it is the caffeine. Caffeine is what we are changing, right? That's what we're manipulating, how much caffeine someone's getting. The dependent variable depends on the independent variable. Maybe that'll help you remember it. But it is going to be the test score. So because in this situation I believe that manipulating caffeine use will lead to higher test scores, I'm going to measure that dependent variable, those test scores, against the independent variable, the caffeine. I hope that helps. Now, when I talk about confounds in this PowerPoint, confounds are anything that can affect your experiment that is not the independent variable or independent variables. So if I'm doing this study with multiple groups, again, I'm going to use the example time of day. I'm not going to give one group a test bright and early in the morning and another group in the afternoon, because even time of day could affect my test scores. And that could affect my cause and effect relationship between caffeine, because maybe the people in the afternoon test better than the people right at 7 o'clock in the morning. So confounds are anything that could affect your results that are not your independent variable. So you want to eliminate those as much as possible. You also want to avoid any bias. Sometimes experimenters have expectations. If I expect people to perform better when they have a couple cups of coffee, then maybe I might see things that fit that hypothesis a little more in the experimental group. So how do I mitigate that? It's not always ill-intended. It just happens sometimes. Maybe they're focused more on those groups. You can do what's called masked designs. So they're previously called, I think they're called blind designs in your book, but I think they changed the term to mask. So a single mask design is that the participants don't know what group they're in. That helps. And a double mask design is that the researchers don't know who's in what group. So for example, in a single mask design, I would be the experimenter. I'll have you all be my participants. In a single mask design, y'all wouldn't know what kind of coffee you got if you were decaf or caffeinated. Hopefully. In a double mask design, y'all wouldn't know what type of coffee you have, and I wouldn't know what type of coffee you have. It's a way to be more objective in data collection. We also want to make sure that participants don't know what group they're in, because participant demands, participant expectations may influence how they behave in the study, or even their thoughts surrounding it. Our mind is a very powerful thing. If you believe you'll do well, you will. There's some validity to that. And so with experiments, we don't want people to behave differently because they know they're being watched or they want to look good, etc. So we try to keep them in the dark as much as possible, so to speak. And eliminating all these things and trying to isolate those variables as much as possible helps us to establish that causality. If you have any questions on variables, I have this great video. It is so basic, like it is not anything super fancy, but it's really good at explaining variables in depth using the example of a track star running with shoes. Please watch it in your PowerPoints on your own time. It's very helpful. And let me know if you have any questions.